In this video, we're going to have a look at proof by induction and a summation question in specific. So with proof by induction, if you guys have done it before, I'm sure you guys know this first step is to do the initial case, which is where you substitute in the lowest value that you can and show that both sides of the investigation are the same. In this case, we can put r equals 1 into the left hand side, and we get that the sum of 1 cubed is just equal to 1, because, well, that's pretty self-explanatory. And if you put n equals 1 onto the right hand side, you get a quarter, lots of 1 squared, lots of 1 plus 1 all squared, which will be a quarter times 1 times 2 squared, which is 4, and that will equal 1 as well. So the initial case holds true. What we can then do is make an inductive statement. We can assume that for when n is equal to k, and k is also greater than or equal to 1, just so we can share that same boundary here, that the sum of the terms of the sequence r cubed, starting from when r is equal to 1 all the way up to the kth term of the sequence, is equal to a quarter of k squared multiplied by k plus 1 squared. So essentially you're just writing this out again, replacing the n with k's everywhere. In a different colored pen, I'm going to write down what we want to show, because that helps us as a reference point later on in the question. We want to show that when we find the sum of the terms of the sequence r cubed from r equals 1 to one term further than this, so to the k plus 1th term, that's going to be equal to a quarter of, and essentially you want to replace everywhere with this k with k plus 1. So we have k plus 1 all squared multiplied by k plus 1, which is k plus 2 all squared. We want to get to this somehow. So let's break this down step by step and see if we can get to it. Well, to start with, for n equals k plus 1, by the way, you always want to use this assumption that you made earlier on in the question. If we're adding up the terms of the sequence r cubed from when r equals 1 to k plus 1, you're doing r cubed plus the next term plus the next term. So essentially you're adding up all the terms of r cubed from r equals 1 to k, and then you're also adding on top of that what you get when you put k plus 1 into r cubed. So k plus 1 all cubed. The reason I wrote it out like this is we can now use the inductive statement. We can replace this with this here, because we've assumed it for this induction. I'm going to change color again because I know a lot of students like it when I use different colors for different reference points, but we can replace this by this term that, like I just mentioned before. So we have a quarter k squared multiplied by k plus 1 all squared, and then we have this here. I've been informed before by students that my k's look not the best, so sorry about that. From these two terms here, we're able to factor out k plus 1 squared, and when we do that, we have k plus 1 all squared, and then you can put a big bracket. To go from this first term to this first term here, you multiply by a quarter and k squared. To go from this term to this second term here, you multiply by k plus 1, so we add on to it k plus 1. We're almost there, but we want to use this as our reference point, like I mentioned before. So what we can do is factor out a quarter from this whole bracket, and when we do, we get a quarter, and then we have this term here, k plus 1 all squared, all multiplied by what you get when you divide each of these terms by a quarter. So we get a k squared plus 4k plus 4, and then you can represent this bracket here as k plus 2 all squared, and just like that you've got to where you want to get to. So let's just write that out very quickly. A quarter k plus 1 all squared multiplied by k plus 2 all squared. I'm sure you guys already know this, but when you square a bracket, it's the same as multiplying it by itself, and so this is like representing k plus 2, which is why we can represent this in this format, which we can reverse into that format there. But yeah, this is a rule of general, is how you do proof by induction for all summation questions. Hopefully this video helped. Be sure to leave a like if it did, and subscribe. I'd appreciate it a lot. Thanks for watching. Thanks for watching the video. I hope it helped. If you have any tutoring inquiries for A-Level Further Maths, be sure to hit my website up at www.excellineducation.co.uk.